Welcome back to AgriCraft, where we explore the cutting-edge innovations transforming global agriculture. I'm your host, and today we're taking you inside one of the world's most rapidly expanding livestock industries that most Americans have never heard of. Did you know that over 12 million camels are currently raised in commercial farming operations across the Middle East, Africa, and Australia, producing more than 2 billion liters of milk annually, and generating over $8 billion in global revenue? That's right. Camel farming has evolved from ancient nomadic traditions into a sophisticated industrial agriculture system, complete with automated milking parlors, climate-controlled breeding facilities, and state-of-the-art processing plants. But how do you industrialize an animal that was domesticated to survive in some of Earth's harshest environments? What does it take to process camel milk and meat on a scale that rivals traditional dairy and beef operations? And why are forward-thinking American agricultural entrepreneurs starting to invest in camel farming ventures right here in the United States? All will be revealed in this video, as we journey from massive camel ranches in the Australian outback to high-tech processing facilities in the UAE, uncovering the remarkable transformation of camel agriculture, from traditional herding to modern industrial farming. The domestication of camels stretches back over 4,000 years, making these remarkable animals one of humanity's oldest agricultural partners. What began as essential survival tools for desert peoples has evolved into a global industry that's experiencing unprecedented growth. The modern camel farming revolution started in earnest during the 1980s when Middle Eastern countries began investing heavily in agricultural diversification programs designed to reduce dependence on oil revenues and increase food security. Today's camel industry bears little resemblance to the traditional herding practices most people imagine. The largest single camel operation in the world, located in Saudi Arabia, houses over 40,000 animals across multiple facilities equipped with computerized feeding systems, automated milking equipment, and climate-controlled housing that would be familiar to any modern dairy farmer. This operation alone produces over 30 million liters of camel milk annually, processing it through facilities that rival any major dairy processing plant in terms of technology and capacity. The economic impact of modern camel farming extends far beyond milk production. Camel meat has become increasingly popular in international markets, with premium cuts selling for prices comparable to high-end beef. The global camel meat market, valued at over $2 billion annually, continues to expand as consumers discover the unique flavor profile and nutritional benefits of camel protein. Unlike traditional livestock, camels convert feed to protein with remarkable efficiency, while requiring significantly less water than cattle or sheep. What makes camel farming particularly intriguing for American agriculture is the animal's adaptability to marginal lands unsuitable for traditional livestock. Camels thrive in arid and semi-arid regions where cattle and sheep struggle, making them ideal for expanding agricultural production into previously unusable areas. Several American entrepreneurs have already established camel farms in states like Texas, Nevada, and Arizona, capitalizing on the growing demand for alternative proteins and specialty dairy products. The nutritional profile of camel products provides compelling advantages over traditional livestock. Camel milk contains 3 times more vitamin C than cow milk, significantly higher levels of iron and calcium, and naturally occurring insulin-like proteins that make it suitable for many people with dairy sensitivities. Camel meat is lower in cholesterol than beef or lamb while providing comparable protein content, making it attractive to health-conscious consumers seeking alternative protein sources. Modern camel farming operations have achieved remarkable production efficiencies through selective breeding programs that focus on milk yield, meat quality, and adaptability to intensive farming conditions. The best dairy camels now produce over 20 liters of milk daily during peak lactation, compared to traditional camels that typically yielded only 3 to 5 liters per day. These improvements result from decades of careful genetic selection combined with optimized nutrition and housing systems. Let's now explore how these remarkable animals are raised in modern commercial operations, starting with the breeding programs that form the foundation of industrial camel farming. The breeding programs that drive modern camel farming operations represent some of the most sophisticated genetic selection work being done in livestock agriculture today. Unlike traditional camel husbandry that relied on natural selection and environmental adaptation, commercial camel farms employ advanced reproductive technologies including artificial insemination, embryo transfer, and genetic testing to optimize herd performance. The largest operations maintain detailed genetic databases tracking lineages across thousands of animals, identifying superior breeding lines that combine high production with disease resistance and longevity. Breeding selection begins with careful evaluation of parent stock based on multiple performance criteria. Female camels selected for breeding typically demonstrate superior milk production, with the best animals producing over 18 liters daily during peak lactation. These elite females also show excellent maternal instincts, consistent breeding performance, and strong disease resistance. Male breeding camels are chosen for their genetic potential to improve offspring performance, with proven sires commanding values exceeding $50,000 due to their contribution to herd improvement through artificial insemination programs. The reproductive management in commercial camel operations utilizes sophisticated hormone synchronization protocols that allow precise timing of breeding cycles. Unlike cattle that breed year-round, camels have evolved seasonal breeding patterns that modern farming operations modify through controlled lighting, nutrition management, and hormone treatments. These interventions allow farms to achieve more consistent milk production throughout the year rather than dealing with the pronounced seasonal variations typical of traditional camel husbandry. Artificial insemination has revolutionized camel breeding by allowing superior genetics to be distributed across large numbers of females, without the costs and logistics of maintaining multiple breeding males. The AI process requires specialized techniques adapted to camel anatomy and behavior, with trained technicians using equipment specifically designed for these large animals. Success rates for AI in camels now exceed 70% in well-managed operations, comparable to results achieved in modern cattle operations. Pregnancy diagnosis in camels utilizes ultrasound technology similar to that used in other livestock species, but with techniques adapted for the 13-month gestation period. Typical of these animals, regular pregnancy monitoring allows farm managers to optimize nutrition for pregnant females and plan for calving seasons that maximize operational efficiency. The extended gestation period actually provides advantages in production planning, as managers can predict birthing periods with greater accuracy than faster breeding livestock. Housing systems for breeding camels combine traditional understanding of camel behavior with modern agricultural engineering. Breeding facilities feature large paddocks that allow natural social behaviors while providing shelter structures that protect animals from extreme weather conditions. The housing designs accommodate the significant size differences between male and female camels, with breeding areas specifically configured for safe mating while minimizing stress and injury risks. Nutrition management for breeding camels requires specialized knowledge of their unique digestive systems and nutritional requirements. These animals are natural browsers that have evolved to extract maximum nutrition from low-quality forage materials. Commercial operations provide balanced rations that optimize reproductive performance while maintaining the digestive health that makes camels so efficient at converting marginal feedstuffs into valuable products. The feeding systems in modern camel operations often utilize automated equipment similar to that found in large dairy farms, but scaled up to accommodate the size and feeding behaviors of camels. Total mixed ration systems blend various feed ingredients including hay, grain, and specialized supplements into consistent mixtures that ensure all animals receive balanced nutrition. Feed bunks are designed with appropriate dimensions for camel head size and feeding posture, preventing competition and ensuring adequate intake for all animals. Water systems in camel farming operations must account for these animals' famous ability to consume large quantities of water when available while surviving extended periods with limited access. Modern facilities provide constant access to clean water through automatic watering systems, but the distribution infrastructure must handle the fact that camels may drink over 100 liters at a single watering session. Storage and pumping systems are sized accordingly to meet these unique demands. Young camel management begins immediately after birth with procedures designed to ensure strong maternal bonding while establishing the human contact necessary for later handling in intensive systems. Newborn camels, called calves, are much larger than other livestock young, typically weighing 30 to 40 kilograms at birth. This size requires modified handling equipment and procedures compared to other livestock operations. The nursing period for camel calves extends much longer than other livestock, with natural weaning occurring at 12 to 18 months of age. Commercial operations often implement controlled weaning programs that separate calves from mothers for portions of each day, allowing milk collection while maintaining the maternal bond necessary for proper calf development. This partial weaning system requires sophisticated management to balance calf nutrition with milk production goals. Growth monitoring in young camels involves regular weight measurements and health assessments that track development against breed standards and production goals. The extended maturation period means that camels don't reach breeding age until 30 to 40 months, requiring sustained investment in feeding and care before animals begin generating revenue. However, this extended development period results in larger, more productive animals that justify the additional investment. Health management in camel operations requires veterinary expertise in species-specific diseases and conditions. While camels are generally hardy animals with excellent disease resistance, they can be susceptible to certain respiratory and digestive conditions when housed intensively. Preventive health programs include vaccination protocols, parasite control measures, and regular health monitoring that identifies problems before they impact production or animal welfare. Record-keeping in commercial camel operations tracks individual animal performance data, including breeding dates, production records, health treatments, and genetic information. Modern farms utilize computerized management systems that integrate breeding records with production data, allowing managers to make informed decisions about which animals to retain for breeding and which to market for meat production. These management systems are essential for optimizing the long-term genetic improvement that drives profitability in camel farming. Now, let's examine how these carefully raised camels are managed during the harvesting and initial processing stages that prepare their products for industrial processing. The harvesting stage in commercial camel operations encompasses both milk collection and meat production, with each requiring specialized systems and procedures adapted to the unique characteristics of these large animals. Milk harvesting represents the primary revenue stream for most camel farming operations, requiring sophisticated milking systems that accommodate animals weighing 600 to 800 kilograms, while maintaining the hygiene standards essential for dairy product safety. Modern camel milking facilities utilize automated milking parlors similar to those found in large dairy operations, but with equipment specifically engineered for camel anatomy and behavior. The milking parlor design accommodates the height and size of camels while providing safe, efficient access for milking equipment attachment. These facilities typically feature elevated platforms that position workers at appropriate heights for equipment attachment and monitoring during the milking process. The milking equipment itself requires specialized vacuum systems and pulsation patterns adapted to camel mammary anatomy. Camel udders differ significantly from cow udders in both size and milk ejection patterns, requiring milking systems with modified vacuum levels and pulsation rates. The teat cups are larger than those used for cattle, and the milk flow rates are adjusted to accommodate the different milk letdown characteristics of camels. Milk collection scheduling in camel operations typically involves twice daily milking, similar to dairy cattle operations, but with timing adapted to camel behavioral patterns. Many operations milk camels early in the morning and late in the afternoon, avoiding the heat of midday when these desert-adapted animals are less active. The milking process for each animal takes slightly longer than cattle milking due to the larger milk volume and different flow characteristics. Quality control during milk collection involves immediate testing for temperature, acidity, and contamination using automated systems that screen each animal's milk before it enters the bulk storage system. Any milk that fails to meet quality standards is automatically diverted and discarded, preventing contamination of the entire batch. Temperature control begins immediately during collection, with milk being rapidly cooled to preserve quality and prevent bacterial growth. The milk storage systems in camel operations utilize refrigerated bulk tanks similar to dairy farms, but sized appropriately for the volumes produced by camel herds. These storage systems maintain milk at precisely controlled temperatures while providing agitation to prevent separation and ensure consistent quality. The storage capacity must accommodate the twice-daily collection schedule while providing adequate volume for transport to processing facilities. Transportation of camel milk to processing facilities requires specialized tanker trucks, equipped with temperature control systems and pumping equipment appropriate for the higher fat content and different flow characteristics of camel milk compared to cow milk. The transport vehicles undergo regular cleaning and sanitization to maintain food safety standards, with documentation systems that track milk from farm to processing facility. For meat production, the harvesting process involves selection of animals that have reached optimal market weight and condition. Camels raised for meat are typically processed at 18 to 24 months of age, when they weigh 400 to 600 kilograms live weight. The selection process considers factors including age, weight, body condition, and market demand for different product types. Transportation of camels to processing facilities requires specialized livestock haulers designed to accommodate the size and behavioral characteristics of these animals. The transport vehicles feature taller loading areas and stronger construction compared to cattle haulers, with non-slip flooring and adequate ventilation for animals that are adapted to arid climates, but may be stressed by confinement during transport. Animal welfare protocols during transport and pre-processing holding require understanding of camel behavior and stress responses. These animals are generally calm and docile when properly handled, but their size and strength require specialized handling facilities and trained personnel. Holding facilities at processing plants provide adequate space and ventilation, while minimizing stress through appropriate lighting and noise control. The actual processing of camels for meat begins with humane stunning procedures adapted for the size and anatomy of these animals. The stunning equipment requires higher power settings than those used for cattle due to the larger head size and thicker skull bones of camels. Trained operators ensure proper stunning placement and effectiveness before any further processing procedures begin. Initial processing steps following stunning involve bleeding procedures that must accommodate the larger blood volume of camels compared to traditional livestock. The bleeding process takes longer than cattle processing due to the animal size, requiring specialized equipment and procedures to ensure complete bleeding while maintaining meat quality. Blood collection systems capture this valuable byproduct for further processing into blood-based products. Skinning procedures for camels require specialized techniques and equipment due to the thick, tough hide that has evolved to protect these animals from harsh desert conditions. The skin removal process utilizes mechanical skinning equipment designed for large animals, with operators trained in techniques specific to camel anatomy. The hides represent significant value and are processed separately for leather production. Evisceration of camels follows food safety protocols similar to other meat animals, but with procedures adapted for the larger internal organs and different anatomy of camels. The removal of internal organs requires careful technique to prevent contamination of meat surfaces, while preserving organs that have commercial value for specialty food markets or byproduct processing. Carcass washing utilizes high-volume, high-pressure water systems to remove any contamination and prepare carcasses for further processing. The washing procedures are more extensive than smaller animals due to the surface area involved and the need to ensure complete removal of any hair or debris that could affect product quality or food safety. Initial carcass inspection involves trained inspectors who examine animals for any signs of disease or conditions that could affect meat safety or quality. This inspection process follows international food safety standards adapted for camel processing, with detailed documentation of findings and appropriate disposition of any carcasses that do not meet standards. Carcass chilling requires specialized refrigeration systems capable of rapidly cooling the large carcass mass to safe storage temperatures. The chilling process typically takes longer than smaller animals due to the size and mass involved, requiring precise temperature and airflow control to ensure uniform cooling while preventing surface drying or bacterial growth. Now let's explore the sophisticated processing operations that transform raw camel milk and meat into the wide variety of products that reach consumers around the world. The processing stage of camel products involves sophisticated industrial facilities that rival any modern food processing operation in terms of technology, automation, and quality control systems. Camel milk processing plants utilize stainless steel processing equipment designed to handle the unique characteristics of camel milk, including its higher protein content, different fat globule structure, and naturally occurring antimicrobial compounds that affect processing parameters. The initial processing steps for camel milk begin with standardization procedures that adjust fat and protein content to meet specifications for different product types. Unlike cow milk processing, camel milk standardization must account for significant seasonal variations in composition and the different behavior of camel milk proteins during processing. Automated systems monitor composition in real time and make adjustments to ensure consistent product quality. Pasteurization of camel milk requires modified time and temperature parameters compared to cow milk due to the different protein structures and heat sensitivity characteristics. The pasteurization systems utilize high-temperature short-time processing with precise temperature control that eliminates pathogens, while preserving the unique nutritional and functional properties that make camel milk valuable. Quality control systems continuously monitor pasteurization effectiveness through automated testing equipment. The homogenization process for camel milk utilizes specialized high-pressure homogenizers, designed to break down the naturally larger fat globules found in camel milk. This process requires different pressure settings and multiple-stage homogenization to achieve the smooth texture expected in modern dairy products. The homogenization equipment must handle the higher viscosity and different flow characteristics of camel milk compared to conventional dairy processing. Separation processes in camel milk processing utilize high-speed centrifuges to separate cream for butter production and skim milk for various product applications. The separation equipment requires modification for camel milk due to the different density characteristics and fat globule behavior. Automated control systems monitor separation efficiency and adjust parameters to optimize yield and product quality. Fermentation processes for producing camel milk yogurt, cheese, and other cultured products require specially selected bacterial cultures that perform effectively in the unique chemical environment of camel milk. The fermentation tanks utilize temperature and pH control systems that accommodate the different fermentation kinetics of camel milk compared to cow milk. Quality control throughout fermentation involves continuous monitoring of pH, temperature, and bacterial populations. Cheese production from camel milk presents unique technical challenges due to the different protein structure and lower casein content compared to cow milk. Specialized cheese-making equipment includes modified coagulation systems and pressing equipment designed for the different curd characteristics of camel milk cheese. The aging processes often require extended periods and controlled environmental conditions to develop the desired flavor profiles. Concentration processes for producing camel milk powder utilize spray drying equipment modified for the higher protein content and different drying characteristics of camel milk. The spray drying systems operate at controlled temperatures and residence times that preserve nutritional quality, while achieving the moisture content necessary for shelf-stable powder products. The resulting powder requires specialized packaging to prevent moisture uptake and maintain quality. Meat processing for camel carcasses begins with fabrication procedures that break down the large carcasses into primal cuts, suitable for further processing or retail sale. The fabrication process requires specialized bandsaws and cutting equipment designed for the size and density of camel bones and meat. Skilled butchers trained in camel anatomy ensure optimal yield and cut quality while maintaining food safety standards. Primary processing of camel meat involves reducing primal cuts into retail cuts, ground meat, and specialty products using equipment similar to beef processing but scaled appropriately for the different muscle structure and meat characteristics of camels. The cutting equipment includes large capacity grinders, slicers, and portion control systems that handle the unique texture and composition of camel meat. Secondary processing operations produce value-added camel meat products including sausages, processed meats, and specialty items that capitalize on the unique flavor profile of camel meat. These processing lines utilize specialized mixing equipment, stuffing machines, and cooking systems adapted for camel meat characteristics. Recipe formulations account for the different fat content and protein structure compared to traditional meat products. Quality control throughout meat processing involves multiple inspection points where trained personnel examine products for color, texture, temperature, and any potential defects. Automated systems monitor processing temperatures, pH levels, and other critical control points that ensure food safety while maintaining product quality. Laboratory testing programs verify microbiological safety and nutritional composition of finished products. Byproduct processing operations handle the various non-meat components of camel processing including hide, bones, organs, and blood. Hide processing involves specialized tanning operations that produce leather products valued for their durability and unique characteristics. Bone processing systems produce gelatin, bone meal, and other valuable products through rendering and chemical extraction processes. Organ processing focuses on specialty food products popular in certain cultural markets where camel organs are considered delicacies. These processing operations maintain strict temperature control and hygiene standards while preserving the flavor and texture characteristics valued by consumers. Specialized packaging systems protect these perishable products during distribution to specialty food markets. Blood processing operations collect and process camel blood into various products including blood sausages, protein extracts, and pharmaceutical applications. The blood processing equipment handles the large volumes and different characteristics of camel blood compared to other livestock species. Strict quality control ensures these products meet food safety and pharmaceutical standards. Industrial machines throughout camel processing facilities include automated conveyor belts that move products between processing stations while maintaining temperature control and preventing contamination. These conveyor systems are designed to handle the weight and size of camel products while providing the flexibility necessary for efficient processing flow. Cleaning and sanitation systems throughout processing facilities utilize automated cleaning equipment that ensures all product contact surfaces meet hygiene standards between production runs. The cleaning systems include high-pressure washers, chemical dispensing equipment, and sanitizing systems specifically designed for the equipment and facility configurations used in camel processing. Now let's examine the sophisticated packaging and distribution systems that deliver camel products to markets around the world. The packaging stage of camel product processing involves highly automated systems designed to preserve product quality while meeting the diverse requirements of international markets. Fresh camel milk packaging utilizes aseptic packaging technology that extends shelf life without refrigeration, making camel milk products viable for export to markets where refrigerated distribution infrastructure may be limited. These aseptic packaging systems operate in sterile environments with automated filling equipment that prevents contamination while achieving precise volume control. Ultra-high temperature processing combined with aseptic packaging allows camel milk products to achieve shelf lives exceeding 6 months at ambient temperature, opening markets that would be impossible to serve with conventional refrigerated dairy products. The packaging materials themselves are multi-layer composites that provide excellent barrier properties against light, oxygen, and moisture, while maintaining structural integrity during handling and shipping. Refrigerated camel milk products utilize conventional dairy packaging systems adapted for the different viscosity and foam characteristics of camel milk. The filling equipment requires modified parameters to handle these differences while maintaining accuracy and preventing product waste. Automated capping and sealing systems ensure package integrity, while applying tamper-evident closures required for food safety compliance. Camel milk powder packaging involves specialized systems that handle the hygroscopic nature of these products while preventing moisture absorption that could affect quality and shelf life. The packaging equipment operates in controlled humidity environments, with automated weighing and filling systems that ensure accurate package weights, while preventing product exposure to moisture during packaging. Nitrogen flushing systems remove oxygen from powder packages before sealing to prevent oxidation and extend shelf life. The packaging materials include moisture barrier films that prevent humidity penetration, while providing adequate strength for handling and shipping. Quality control systems verify package seal integrity through automated leak detection equipment. Frozen camel meat packaging utilizes blast freezing systems that rapidly reduce product temperature to preserve quality and texture. The packaging equipment handles the large size and irregular shapes of camel meat cuts, while applying vacuum packaging that removes air and prevents freezer burn during storage. Automated labeling systems apply product information and regulatory required markings including processing date and facility identification. Fresh camel meat packaging systems maintain strict temperature control throughout the packaging process to ensure food safety and quality. The packaging materials provide excellent barrier properties against oxygen and moisture, while allowing the meat to maintain its natural color and appearance. Automated weighing and pricing systems ensure accurate package weights and consistent pricing for retail distribution. Value-added camel meat products such as sausages and processed meats utilize specialized packaging equipment designed for these product types. The packaging systems include vacuum packaging for extended shelf life, modified atmosphere packaging that preserves color and prevents spoilage, and conventional packaging for products with shorter shelf lives but immediate consumption requirements. Camel cheese and fermented products require packaging systems that accommodate the continued fermentation or aging processes while protecting products from contamination. The packaging materials allow controlled gas exchange while preventing moisture loss and maintaining the environmental conditions necessary for proper product development. Cold storage facilities adjacent to packaging operations maintain precisely controlled temperatures and humidity levels appropriate for different camel products. Fresh milk products are stored at temperatures between 2 and 4 degrees Celsius, while frozen meat products are maintained at temperatures below -18 degrees Celsius. Automated monitoring systems continuously track environmental conditions, with alarm systems that alert operators to any deviations. Distribution logistics for camel products begin with order processing systems that coordinate customer requirements with production schedule.